Alright, the next topic is about significant figures. So what are significant figures? And significant figures are like pretty much the way of estimating the level of uncertainty in a measurement. For instance, like in your classroom, let's say a student measured the width of that classroom and then he came up with the value 10. Another student did the same side and he came up with 10.0, and a third student came up with 10.00. So the thing in here, what you see is like there is a certain level of accuracy in those three numbers. So as you can see here, the first student cannot tell reliably like what would be coming after 10. Okay, so that means he's the least accurate. But if you check the third person, you can tell like what comes right after 10. After 10, there's nothing, 10.0. And then after that 0, what's coming? He can also tell reliably, like his measurement is 1/100th more accurate than the first one. That means the third guy. So a significant figure is one of that is reliably known. Okay, so in any measurement, like if a number is non-zero, then it's a significant number. Okay, so as you can see, like here in this example, like as you can see, like you have 10, right? For instance, how many significant figures do you have? You can claim that like, oh well, I only have like one significant figures, or some textbooks may say like, oh, there's also a 0, and it's a very tricky kind of thing. Why we are saying that? Because if a value is non-zero in your measurement, then it's a significant figure or significant value. But the tricky part is always when zeros are involved. So in those three measurements, like which zeros are significant, which zeros are not significant. So to answer this question, what we're going to do is we're going to go to the next table. So there are a certain set of rules that we need to follow. Okay. Then based on that, then we'll try to say like how many significant figures you have in a certain measurement. So rule number one, it says like zeros between other non-zero digits are significant. That means, as you can see, like on the right column, there is an example for rule number one. It says like 50.3. As you can see here, like 0 is between 5 and 3. As a result, that 0 is a significant number. Therefore, 50.3 mirror has three significant figures. Likewise, example B shows you like 3.00 to 5 seconds. The two zeros that you see, they are between a non-zero value 3 and another non-zero which is 2. So therefore, those two zeros are significant figures. As a result, like it has 5 significant figures. Rule number 2 is zeros in front of non-zero digits are not significant. So that means an example as it's indicated 0.892, then the 0 right before the decimal point is not significant because there is not any other non-zero number in front of it. So likewise, in example B, you only have like one significant figure, right? 0.0008. How many significant figures do you have? Well, that's the number of significant figures you can reliably tell, which is 1. That's as simple as that. Like, if there is no any non-zero value before those 0 values, therefore they are not significant. Okay. Rule number 3, as you can see here, it says zeros that are at the end of a number and also to the right of the decimal are significant. Okay. If they are at the end of a non-zero value or a significant. So therefore, 57.00 gram has 4 significant numbers. Why? Because the person who measured that measurement can reliably tell up to 2 more decimal places after the decimal point. Okay, 2.00000 has 7 significant numbers because the person who did that measurement can tell a measurement that's so reliable that like it can tell up to 1/1,000,000 after the decimal place. Okay, so as a result, like that is a more accurate value, and those zeros are significant. Okay, so like, but how about like whenever you have no decimal point but just simply just the number? As in the previous slide that I was asking you, like, what is the significant number that you have in 10? That's 1 and 0. So there are like different rules that you may encounter when you are looking at decimal places, especially when they involve like numbers like 10, 100, 200 without decimal places. So how many decimal places are you expecting there? So the question is, whenever you have this, we're going to use a simple rule that says like, if there's no any decimal point, it says zeros at the end of a number but to the left of a decimal are significant if they are measured or at the first estimated digit, but otherwise they are not. But in this textbook, they will be treated as not significant. Some books place a bar or something like that, but in this book, we are not going to go through that. So if you have a number that says, as an example, 1,000, then the only significant number that you have in here is just 1. Okay. And then in a measurement like 20, the only significant number that you have in here is also a 2. Okay. So those are the simple rules that you need to follow. Then as far as you follow those rules, it's pretty much simple. So you can see, like in those examples, what is the answer for A, for example? According to rule number 2, what we said is like zeros in front of non-zeros, they are not significant. As a result, A has just 1 significant figure. For B, according to rule number 1, if you have zeros like between non-zero values, then that is significant. As a result, B has 3 significant figures. C, on the other hand, it only has 1 significant figure, according to rule number 4. Okay. D has how many significant figures? D has 4 significant figures. Okay. Then now let's move to other rules that involve significant figures. What if like you are involved with additions and subtractions and divisions and so on and so forth? How do you tell like the exact significant figure? So when you are adding and subtracting, so you need to round the number to the smallest number of decimal places. Keep in mind, the word is here decimal places, not significant figures. So as an example, you can look at like on the left side of the slide, 77.3 plus 4.85. When you add those ones in your calculator will give you a value 82.15. But the thing is, the number of decimal places after the decimal point that you have, that means the least reliable value is the 77.3. As a result, your answer must have just only 1 decimal place after the decimal point. So therefore, that 82.15 has to be rounded up to a value 82.2. Okay. Then how about like, what if you have numbers that are multiplying and dividing? So whenever you have such things, the number of significant figures in the final result is the same as the number of significant figures in the least accurate of the factors. Okay. So as an example here, if you multiply 123 by 5.35, the result will be 658.05. But the question is, which one is the least number, the least accurate number? Okay, the least accurate number means like the one that doesn't have any decimal place. As a result, here what you have to stick with is like 123. So 123 is the least, the the least accurate, at the same time like equal number of significant figures. So therefore your answer has to be 658. It has to be rounded to 658. Same number as, same significant number as the least accurate number, which is 123 in this case. Okay. Then further examples like, so use your calculators. I want you to challenge yourself, go ahead and then try to solve those ones. So how many significant figures do you have, or put the proper rounding based on the rules and the principle that we just saw in the previous slide. So for part A, if you plug in those numbers in your calculator will give you this number, which is 2.96 times 10, 296, 2,960,000,000. That's the number that you're going to get from your calculator. But the thing is, if you put this in terms of scientific notations, or according to the rules that we saw, the number 4 in the table that we saw a couple of slides ago, the rule states that like if you have zeros after any zero values, then they're not significant. Okay. As a result, like you only have 3 significant figures in this example. If you plug in the numbers in question B in your calculator, and then your calculator will produce a value 0.06876365146. Okay. But the thing is, if you look at the least number of significant figures in B, the least number of significant figures in B is 4. Okay. So this number of significant figures that you have, like you have 3 numbers, right? So 3 numbers that you are multiplying and dividing in question B. You look at the least number of significant figures, and then based on that least number of significant figures, you can only put in 4 significant figures in your answer. As a result, 6.876 times 10 to the power of minus 2 will be the answer that contains 4 significant figures. Okay. So with this we conclude the significant figures topics. Then see you in the next topic.